Alright, so today we're going to talk about systems of inequalities, which, by the way, I'm still a little confused on. It seems like a lot of people did equations, so if I'm misreading something, just pretend it's equations. But I'm doing inequalities. So we're going to look at this problem here real quick. It says you can work at most 20 hours next week. You need to earn at least $92 to cover your weekly expenses. Your dog walking job pays $7.50 per hour, and your job as a car wash attendant pays $6 per hour. Write a system of linear inequalities to model this situation. So I've already set up my system of inequalities, and I described what x is going to be and what y is going to be. And I actually did this lesson earlier. My class is actually empty right now. But a lot of times students were using D and C, but they got really confused with how to solve it. They didn't know what to put on the x-axis, what on the y. So in the end, we determined that it's just easier to use x and y and then just say what x and y stand for. I have the money inequality. I like to call it the money inequality because a lot of times your inequalities are money, money, money. So $7.50 for the dog walking, $6 for the car wash, and I have to make at least $92. So I always tell my students that I'm at least 12 years old, which obviously I am older than 12 years old. And then the other inequality we have is the hours from each job. I have no idea how many hours, but it said I had at most 20 hours. So at most I tell my students, if I was having a pizza party, you can have at most 2 slices, which they all know is 0, 1, or 2. And these are the inequalities, and next I'll show you the graphs. Alright, so I have set my graph up already. And the one thing I learned through doing this audit course is to not focus on having the kids set up the graphs because it's tedious, which I realize it is tedious. And so I think for future reflection, I'm going to have the graph maybe already set up for them so they don't have to worry about the intervals, they don't have to worry about what numbers to use. And we're more focused on the mathematics behind a system of inequalities and what it means to solve a system of inequalities. So I color coded my graph, so the green would be my hourly one up here. The orange obviously is my money one. I've set them up already. I would have gone through this with my students, but I'm kind of condensing it for our video. Now I have the arrows because system of inequalities, if you're less than, you're below the line, so everything would be technically shaded green this way, and the orange one, technically everything's up this way. So for a system, in order to find all the possible solutions to a system, we find just where those overlappings would be. I tend to not shade everything all in one direction because then it gets real messy. And some students just refuse to use colored pencil, and they just have one color of pencil and it looks like a big blob. So I just tell them to use these little arrows, and they have to imagine them going forever. And I shaded the inside pink here. This is where all my possible solutions are going to be. So these are solutions that would satisfy both of these equations at the same time. If I'm up here, it would only satisfy the orange equation and not the green one, because the green one's going down. If I'm down here, it's only going to satisfy the green equation, and the orange one's pointing up. So I need to be in between to satisfy both of these equations at the same time. And we're going to go through the algebraic process of proving that they're definitely both going to be solutions to both of those equations, inequalities. Okay, so now that we've had the shading, we want to test a point algebraically to make sure that it is actually going to be a true point. So we have 2 points here. I picked one that's in the shading, and that's where I said it's going to be a true statement. And I picked the point 10, 8, so 10, 8. And I picked one that's down here that's 10, 2. We're going to see what the difference is between a point that's in our shading where they overlap and one that's not. Now, technically, this would be in the green. Use your imagination. The green's going down. So how does it portray out in an algebraic way of looking at it? So we took this 10, 8, and I modeled it up here. And I took my 2 equations, and I substituted in my 10 and my 8. So I plug in 10 and 8 for the hourly one. 18 is less than or equal to 20, so that satisfies that inequality. And here I have 75 plus 48, doing this right here, greater than or equal to 92. 123 is greater than or equal to 92. So that's good. That's what we need. We need it to satisfy both systems. If it doesn't satisfy both, then we have issues. So then when I take my point of 10, 2, here for the hourly one, 10 plus 2, 12, that's less than or equal to 20, so I'm still working less than or equal to 20 hours, so that's good. But then when I get over here, here's where I have some issues. I plug in my points to test, and I get here, and I have 75 plus 12, but then I get 87, and that is not greater than or equal to 92. So even though it satisfies my one equation, it completely fails in this equation. I'm not getting enough money for my goal. So it's got to satisfy anything in this shaded region. And trust me, you pick any point in here, and it will satisfy that completely, and you will satisfy that inequality, and everything will be good to go. So hopefully you enjoyed that. Hopefully it made sense. Hopefully I did the right assignment.